поверненням. Зараз у нас доповідь від Stefana Baumgartner. So I switch to English. Stefan is the AIDA dev owner. He is the author of TypeScript in 50 lessons and the TypeScript cookbook. In his spare time, he organizes ScriptConf and Rust Links. Stefan enjoys Italian food, Belgian beer, and British vinyl records. And today, Stefan will tell about lies we tell ourselves using TypeScript. Please welcome.
Hi, and welcome to my talk, Lies We Tell Ourselves Using TypeScript. I'm terribly sorry that I can't be with you in person today or live online. I have other duties, unfortunately, but I still hope you find something out of this recording and you get some good and nice information out of it. So first of all, again, I'm terribly sorry. I'm sure you have seen a ton of great talks today. There have been lots of great information for you and lots of new things to learn. And now I'm here, and this is not going to be a fun talk. I will crush your hopes. I will destroy your dreams. You will suffer now for a little bit. And I'm very, very sorry for that. You know, I've done my fair share of TypeScript in the past. So I've written 2 books on TypeScript. I spent a great deal with the programming language, and I know the intricacies pretty much in and out. I know where teams struggle. I know where teams need to put some extra effort in. And usually when I start one of my TypeScript books or TypeScript workshops, I start with an example where every line is wrong, like this one. But it does parse, it's JavaScript, it doesn't produce any runtime errors, it just doesn't work as intended. And TypeScript can find all those errors pretty easy. Look at it. Those were 10 errors that TypeScript could see by just looking at your source code. This is great. This is what TypeScript is for, and this is what we're actually looking for. But not today. I'm not talking about this today. I'm talking about the total opposite. This here. This is some TypeScript code that's well typed and complete. It compiles, it runs, it throws errors at runtime. You know, that kind of errors that TypeScript is supposed to prevent. In just 2 functions. One fetches data and the other one concatenates the result to an existing array. If that's too much for you to read, there's lots of heavy type annotations in it. Don't worry, let's go through it step by step. We have some function overloads, which is nice. I love function overloads. I think function overloads are the unsung hero of TypeScript, where you can define an API to the outside world that tells you exactly what to expect when you call this list entries function with species or people. That's a string literal type. Function overloads are fantastic to do that. First, you have the overloads for the API to the outside, and then you have the function signature for the inside. Let's look at the function body. This is the core of the first function. We fetch some data from the Star Wars API, and then we pass it as JSON and return the results. If you don't know SWAPI, Star Wars API, it's a great way to have a REST API that you can try out, where you can test a couple of things that you know that you got CRUD right, and this is also what we are doing here. The stuff from the Star Wars API is wrapped in some meta information. We don't care about that meta information. We are just here for the real deal. So we unwrap it, we call result.json. And we also have some error handling in case something goes wrong when parsing JSON. Great. And last but not least, we have a simple function that takes 2 arrays and concatenates them. Very good. And in the end, we're using our function. Define an empty list, an empty array, and append data via a call to list entries. That's what we do. 2 functions, one fetches data, the other one concatenates the results to an existing array, and that's pretty much your standard TypeScript fare. You can argue about coding style, maybe something is not quite right as it should be, but you know what? That's code that you and I might have written, or that some of your colleagues might have written. That's code that ends up in people's code bases, stuff that passes the review. So you might ask yourself, what do you think can go wrong? Well, I'd say everything. Actually, every line of code in this example goes wrong. Where does it go wrong? Everywhere. And when does it go wrong? Well, one by one, because JavaScript is single-threaded. Brings me to my most favorite joke about JavaScript. Knock, knock, race condition. Who's there? Anywho, let's go through all those problems step by step. Welcome to chapter 1, A Tale of Fetch. There's one damned lie hidden in this statement. I'm doing a type annotation. I say what comes back from result.json is of type meta people, and this line only works because the JSON method from the interface body returns any. And any is the happy-go-lucky type in TypeScript. Everything is possible, and if you say that data is meta people, then TypeScript is like, well, okay, whatever. You know best, it's your responsibility, and your program goes boom. And there's lots of hidden any's in TypeScript, which, are there for convenience sake. It's good that we have them. Otherwise, TypeScript wouldn't have gotten this adoption because there's also lots of any in JavaScript. But this is one thing where you can just annotate whatever you like and TypeScript will be okay with it. And you need to be aware of that. What we see here is TypeScript at its boundaries. TypeScript defines a type model or types of your model, if you will, that work pretty well when you are within the TypeScript world. But you rarely have software that is just within your own boundaries. You have software that reaches out to APIs from other pieces of backend, for example, or you have user input. Everything that is I/O, API calls, you name it. This is where you need to do extra checks to make sure that whatever happens is actually what you intend to happen. I'd like to call type assertions to be an unsafe operation. Sorry, not type assertion. I'd like to call anything that includes any, or that is at its boundaries, an unsafe operation. And I think we need to make unsafe operations visible. And there's something that we can use to make unsafe operations visible. For example, indicators like type assertions as meta people. It's much more visible that here we are bending the type system to our needs instead of just annotating something and be done with it. Or having a type predicate or assertion signature. Those are keywords that we then can look for and see that stuff is going wrong or that we need to take extra care of things. If you just have an annotation like that, a type annotation like meta people on the type of any, well, how do you find that later on? How do you find all the occurrences where you needed to bend the type system to your will when it just produces any and you can override it with a regular type annotation? The other one, the second line, here it becomes clear. Something is afoot and you need to be aware. And we can make those things visible. This works for a little thing called declaration merging. Interfaces in TypeScript are never closed. You can always add new methods and fields by simply redeclaring the same interface. So here I open the global namespace, I open the body interface, that one that has any in it, and I say the JSON method does not return a promise of any, it returns a promise of unknown. This is a function overload. With that, the last function overload, this is the one that counts most in that regard, and unknown won't let you cut corners. Any is the cautious sibling of unknown. Unknown is the cautious sibling of any, Unknown is the cautious sibling of any, which means that they include the same area of values, but you are not allowed to do anything without a type assertion or without making sure that all those properties exist. So if I'm adding this overload, I'm getting a beautiful type error the moment I try to assign unknown to a known type. Now I need to act. Type unknown is not assignable to type meta people. Now you can do a type assertion as meta people, this still works, or you need to check for its properties. Cool. First problem, first solution. Let's go to the next problem. The theme is dark and full of errors. Let's talk about this funny catch clause and error handling here. It's very interesting. What's going on here? We catch for a syntax error or any? Why did developer do this? Well, in JavaScript, everything can throw. You can throw errors, you can throw objects, you can throw the number 2. JavaScript is actually a little bit like my kids. They can throw tantrums and you don't know where they are coming from. JavaScript is throwing unexpected errors and you have no clue where they're coming from. And with everything being throwable, it's just a false assumption in TypeScript to say that you're catching for one particular error. This is not possible. You only have one catch clause, and this catch clause needs to catch these errors that you have, that come from other APIs, or that can happen anywhere. This is why somebody snuck in a little any. And the code reads right, doesn't it? Well, it's a syntax error coming from result.json, or it's any, because anything can happen. But what the developer didn't realize is that if you put any in a union with syntax error, the whole type becomes any, which allows you to access every property available. That this code didn't blow up at runtime is mere chance. And we are not here for chance, we have a static type system. This is not what we want. Again, unknown to the rescue, there's a mitigation for that. There's a compiler flag where you can turn on unknown in catch variables. This is the default. Then you don't need to do anything. E, or the error, will be unknown by default, and you need to narrow it down. Like in this example, where we narrow it down through an instance of check to syntax errors. So instance of checks for errors, because errors are objects that are created by, an error class, or function, constructor function. Then you can do an instance of check as well. Good, great. Now we know that we are actually dealing with the right error. Let's look at problem number 3. There's plenty of problems for not many lines of code, isn't it? So we have 10 lines of code, 3 problems already. Okay, the metrics overloaded. I was a huge fan, or I am a huge fan of function overloads. I think they are fantastic, but now I want you to turn your eye to the function overloads. They tell me, they tell me that I get a promise of an array of species when I put in the key species. They tell me that I get a promise of an array of people when I put in a key of people. So far, so good. But in the code, I only return people. In the signature, it tells me I get species, but in the code, I only return people. In the signature, it tells me I get species, but I only return people. And you know what? TypeScript will think it's species. How is that possible? What's happening here? And this is one of the biggest caveats in function overloading. I'm very sorry that those exist, but we need to deal with it. Let's see what those function signatures actually mean. We can pull apart those 3 lines of code. You actually have 2 different kinds of function signatures. First, you have the function signatures that define the usage. This is the API to the outside. And all you see here is that you get species from a key species, you get people from a key of people. That's all you see there. And then you have the implementation function signature. This is just your regular JavaScript function signature. Here we create a union type of species or people, and it returns an array of people or species. That actually in your modeling of this function signature, that checks out. When you use the function, you only get types for the first 2 lines. When you implement the function, you only get information on the last line. And then there's a couple of type checks happening. TypeScript will check that the first 2 lines check out with the 3rd line, so that you don't declare something that you don't implement. Very good. And the other type check is that everything that you return from that function will be checked against the implementation signature. All good. 2 separate type checks. That's true. And usually you design it that way that you are very narrow in your usage signatures and very broad in your implementation signatures. I know people who are using any for all those types because they have a very vast list of function overloads. The problem, nothing checks if your implementation actually matches your usage. So you have the type check from usage to implementation signature and from implementation to implementation body. But the implementation body can be anything that matches to implementation. It doesn't necessarily need to follow the semantics of usage. And this crashes a lot, and I've seen so many folks failing on that one because it's so hard to see, it's so hard to overlook. And you just remove a couple of lines because your function got simpler or your model got simpler, but you forget to remove the overloads, and now you're there. So this is something that you actually need to test. there's also a way to overcome this, which are conditional types. That's a possible mitigation. So with them, you can offer the same parameters and return types as with overloads, but since they're very complex, the type system can't figure out what you're returning is actually what you're supposed to be returning, which means that when you use it like that, you get a beautiful little error here where you say people or species is not assignable to type return T. Now you need to act. Now you need to check on your type. Now you need to do type assertion signatures, type assertions. You know, all the things that are unsafe operations because we are in unsafe territory again. It's great. Arguably, the complexity is something that we need to talk about, but hey, we are getting somewhere, aren't we? Next one. And I guess this is one of my favorites, the unexpected virtue of ignorance. I'm still baffled that this can happen. You know, we are in type-safe territory. After all, this is the second function. I have a function called append entries. Append entries takes a list of people or species, and I concatenate it with another list of people or species that come from a promise. That's just a detail. Fair enough. Since the parameter list is caused by reference, it mutates list, so we don't need to return anything. Mutable element. But now look at the actual usage. So I create a list of people, and I append a list of species. So you might ask yourself, what's the type of list after append entries? It's still people. It's still people. You know, the thing is, for TypeScript, all the contracts are fulfilled. The parameters expect a list of people or species. We are providing a list of people. It's good. It's okay. That's fine. We want to concatenate it with another list of people or species, and we provide another list of people or species. That's fine. So you can take something that is a subtype for something that expects a supertype. That's basic narrow down. That's Liskov, if you want. But TypeScript has no notion for mutation. TypeScript does not know that something changes and the type becomes different. There are a couple of things to do that, like assertion signatures, type predicates, but not for situations like that. So the type is very narrow, and we broaden it accidentally, and we have no way to solve that. So, and you know, well, you can argue that's actually a problem of JavaScript itself, but you know, mutation happens. There's one mitigation. Thankfully, we have mitigations for everything, which is generics. So instead of adding a very broad type, we add a generic type parameter that can be set to a subset of our original type, people or species. The moment we add a concrete value, like the list of people, TypeScript locks T to type and tells us that we can't mix and merge as we see fit. You know, this is the type that we set, and this is the error that we get. Because now, the moment we add list to it, T becomes people. And we get an error that says the argument of type promise species is not assignable to parameter of promise people. Fantastic. Generics are always a really good way if you want to have something much more concrete based on a very broad type. Usually generics solve all your any problems, all your type broadening problems. This is something that I can highly recommend. Please go for generics. And use generic inference, of course. So we have everything mitigated. Fantastic. We highlighted unsafe operations. We got rid of a couple of function overload problems. We now see that we can use generics to make our code more type safe. It should work, doesn't it? So now we have 10 lines of code, 4 problems. We found 4 fantastic solutions. Please enter the final chapter. Lies, damn lies, and TypeScript. So the story for so far. What did we do? We use declaration merging, a fantastic feature in TypeScript where you can open up existing interfaces, put some new content in it, patch assumptions that the type system made for you based on the reality that actually exists. Override anything with unknown. Please use the TS reset library by Matt Pocock. It's fantastic. It does deal with exactly those things. It's great. You make it more type safe without breaking type itself. Declaration merging to patch assumptions. We were pretty more strict with our catch clauses and error types. Now we could do what we needed to do, instance objects. Instance objects are really good if you have classes and create objects with it. It's as far as a type system and type checking that JavaScript has built in. and TypeScript mirrors it perfectly. So use classes wisely. There's lots of debate on whether you should use classes or not, but it's a good way to deal with those things. And well, if you have complex signatures, you can use conditional types. Conditional types are a great way to express yourself. They are very powerful, and you can highlight unsafe operations because they're so complex that TypeScript will mostly evaluate it, but never to the fullest. And last but not least, generics to narrow down to specifics. One of my most favorite tools in TypeScript. Add a generic here and there, and then you are locked into a more concrete type, and you get rid of most of your type problems. But you know what? 4 solutions to 4 problems, and they just contain more lies. Every solution that I showed you comes with 1 more or even many more damn lies. Let's take declaration merging for an example. So here I declare an interface called formData, and the moment I use it in handle form, I suddenly have access to APIs that I haven't defined. Where are they coming from? Where is data.get? Where does the .get method with a string comes from? Well, you know, form data exists already as a global type, and I merge with the global type. And nothing keeps me from it. And you know, form data is a very generic name, and I'm pretty sure some of you have also written a form data interface in their life. So actually, I brought this up at one of my talks, and people came to me and said, yeah, finally, thank you for explaining that we had exact this problem. So yeah, declaration merging is great unless you accidentally merge with globals. Next one, and this is my favorite lie in the entire presentation. You have 2 classes, class A and class B, fantastic. Each has a distinct property, A or B, and you have this doSomething function that accepts both A or B as parameters, a union type. To access the correct properties, I do instance objects. P instance of A, then you have type A, and in the else branch, since you only can pass A or B, well, then it should be B. That's control flow analysis. That's what TypeScript does really, really good. So, fantastic. That's what we want. But then again, TypeScript is a structural type system, which means that you can pass elements which have the same shape as A, not necessarily are an exact instance of A. So yes, for TypeScript, the shape of this object that I pass here and an instance of class A is the same, and it's correct. In a structural type system, it's correct. But the instance object comes from JavaScript, and it only works on instances, not shapes. So yeah, this will cause a problem. I mean, we're just logging it, we log undefined, but what if you, I don't know, calculate something with it? You get an error, you get a runtime error, this breaks. So yeah, instance objects are great until you realize that TypeScript is structurally typed. Next was conditional types. So yeah, anybody can tell me what this does? Anybody? I can't. I've written this, so this is my code. I guess I needed to create overloads for a currying function. I think that at least what curried and overloads tells me, but what does the rest do? Where's all this coming from? And you know, they're powerful. I love conditional types. They're very powerful. Library authors love it because they can create really, really good types that explain the APIs so well, because JavaScript allows for very funky APIs, and now I have a tool to explain them. Great. But you know, ask yourself, is the complexity worth the benefits? Is it something that you would add to your project and be safe that you know what's happening afterwards? You know, that's TypeScript's answer to regular expressions. Same complexity. You need to have documentation to understand what's going on. All right, and the last one, that was generics. Generics are fantastic. I love it. Use generics, but you know, you can always explicitly annotate generics to a broader type, as long as it's within the type boundaries. And if you do that, everything is back to normal again. And well, what should I say? Please be wise with generic instantiation, because once you explicitly set them and make the set byte as they should be, you have the same problems again. So all of our solutions debunked again. Lies, damn lies. I'm very sorry about it. Okay, the epilogue. Again, I'm very sorry. This wasn't a nice talk. I hope I didn't crush your hopes or destroyed your dreams, but I think you suffered as much as I did. And you might ask yourself, what do I think of TypeScript? I've written 2 books about it. You see all those problems that arise. What do I think of it? And you know what? I fucking love TypeScript. Sorry for the cursing here. But it's still the second best language that I have had the pleasure to work with. And I don't want to work without it. Whenever I do Node, whenever I do browser code, I want to work with TypeScript. It's about making you productive. And I can't argue with the fact that TypeScript makes me tremendously productive. The talk is called The Lies We Tell Ourselves using TypeScript, not the other way around. And I think we tell us a couple of lies. The biggest lie, for example, is that we're here to write code. In reality, we are not here to write code. You're software engineers. Software engineering is about decisions and trade-offs. That's your job. That's our job. That's what you're supposed to do. It's one thing to write that stuff. It's another thing to commit to it. And I mean literally commit it into your GitHub repo. And you know who knows pretty good about trade-offs? TypeScript and the TypeScript team. It's an explicit non-goal of TypeScript to be provably sound. That's a pretty bold statement for a type system, I have to say. They want to strike the balance between correctness and productivity. It's a goal to make you productive as hell, making all the little trade-offs that come with the type system that sits on top of a programming language like JavaScript. And that's okay. The TypeScript team are some of the smartest people that I've had the pleasure to meet. It's tremendous what they do to formalize a programming language like JavaScript that's supposed to go haywire when you just look at it. But that's also software engineering. And all those things, all those little flukes and things that we saw today, they know about it. They know about it, they work on it, they try to make it better. But they made a trade-off, they made a decision that this is the current state of affairs. And you need to deal with it because they offer you some fantastic tool. And you need to know its intricacies. You need to know what's going on there. You can only write code if you understand the tool. And that's actually the point that I want to make. Here's the point. Every tool or library that you use has trade-offs that you need to be willing to take. There's no silver bullet. I've shown you 4 problems. I've shown you 4 solutions just to see that there are more problems. And that's okay. That's part of our job to understand that those problems exist. There's no dogmatic solution for everything. I say use generics. And now you're going to set out and use generics for everything? No, of course you don't. It still comes with caveats. Think about if generic is the right tool to solve your problem. This is the question that you should ask yourself. And this also brings me to the whole thing, oh wow, TypeScript is such a bad programming language. Who the fuck cares? Sorry for cursing again. Don't feel yourself superior because you use a certain tool. A language everybody loves to hate is PHP, but here's Taylor Altwell, the creator of the popular PHP framework, showing off his Lambo that PHP bought. So yeah, and then here you have, lo and behold, the Austrian Java Fiat, same vibe, totally. Who cares, Java people, I know some Java people who are very proud in their choice of programming language. Not all of them, but don't feel yourself superior because you use a certain programming language. I'm a Rust developer. Guess what my car looks like? On the other hand, hey, if you look at that, if all you need to do is carry kids and beers, which car does the job? And that brings me to this one message that I want to give you. The last 30 minutes, I was not here to tell you what to do. I'm not here for the 5-minute hot takes that go viral on X or YouTube or TikTok or whatever. I'm here to make you aware that nothing is without its caveats. It's about trade-offs and decisions, and it's about productivity. Be pragmatic. Be aware of the trade-offs you make with the tools you choose. Use this information to find and choose the best way possible for you and your team. No solution is a silver bullet. It's not the best thing possible. It's just a solution. It can work for you, or maybe it doesn't. So don't go for hot takes and dogma. And yes, I know very well that this phrase was just also a very dogmatic advice, but beat me. Alrighty, and with that, I hope you had some fun. I hope you learned something today. I hope it makes you think a little bit. You are not the person writing code. Copilot is, you are the person committing code. And with that, I want to say thank you very much. If you want to get more about TypeScript, please check out my 2 books. TypeScript in 50 Lessons is out now. It's been published in 2020. It's your guide to the type system. If you want to understand the type system, this is the book for it. And if you want to have solutions to real-world problems that people have while coding together in TypeScript, you get 100 more lessons in the TypeScript cookbook, which has just been released. I'm very proud of it. It's a beautiful little parrot on top of it. And with that, thank you very much. And if you need anything, don't hesitate to give me a shout out on X, Mastodon, LinkedIn, wherever you like. Bye-bye.